Okay, so for 432, we're talking about calculating correlation coefficients. You're definitely going to want to watch this video because you really have to use the calculator to do this. And I haven't shown you how to use the calculator with bivariate data, which means two variables, right? Two sets of data, like an X column and a Y column. We've done single variable, which is univariate data, but not bivariate. All right, so we got books read and test scores, right? And if you read the question, it says a research team is intending to determine if there's a relationship between the students' vocabulary and how frequently they read books. The team gives 20 students a 100-question vocabulary test and asks students to record how many books they read per year. The results are in the table below. Is there a linear relationship between the number of books read and the test scores? Use the correlation coefficient R to explain your answer. Okay, so the first thing that I want to show you is what the scatter plot of this data would look like. Okay, so I already have that here. And so there's the scatter plot of this data. And so what we want to determine, is there any kind of fit to this? Would a linear model work for this? And so the linear model, I'm not actually going to draw it because I don't want to mess up my paper here, but the linear model would have to go somewhere through here, right? But there's a lot of spread, if you notice, between the dots on this end and where that line would go. Okay, but the line should run through the middle of the data set. Okay, and what I want you to notice is that on the left side, we're clustered around 0. As we move to the right, we appear to be moving further up, right? So it seems to be a positive, even though we have these slight variations or these data points here that are kind of low, which are throwing off how strong the correlation is. Okay, now I want to talk about what an actual correlation means for a second. So I'm going to go back to my other page here and share this with you. So let's look at this for a second. A correlation is a relationship between two events, such as X and Y, where a change in one event implies a change in another event. The correlation coefficient, R, is a quantity that allows us to determine how strong this relationship is between the two events. So in other words, how closely related X and Y are, right? In other words, how closely does reading a lot of books affect my ability to do well on that vocabulary test in that first example? And the value for R is always going to be between -1 and +1, okay? Just all you'll ever get for R. And again, that'll come from the calculator. You're not going to have to calculate it by hand. So if it's between 0 and 1, that implies a positive slope. Okay, it doesn't mean the slope is between 0 and 1. It just means that the slope itself is positive. And the closer you get to 1, the closer all of the data points will fit that line. If it was exactly 1, that would mean that every data point was exactly perfectly on the same line. Okay, the closer you get to 0, the more scattered or spread out the data is, and the less of a perfect fit it would be. Okay, matter of fact, if it's 0, you would argue that the data is completely scattered, and therefore a linear function, nor any other type of function for that matter, would be a good fit for that data. Okay, now between 0 and -1 is the exact same concept as between 0 and +1, except that it means there's a negative trend to the data. There's a negative slope happening. In other words, your data starts at high, and the further right you go, the more down your data goes. Okay, so that's all that really means. Okay, that's it. So all it does is compare the two. So what I want to do now is go back here, and we're going to figure out how to actually calculate it. And I'm going to show you a couple other things while we're in there too. So this is where I'm going to bring the calculator into play. All right, so we are here, normal calculator screen. Let me do this way so I don't get the glare. So I'm going to hit data. Okay, and I've already plugged in these numbers. You can look behind me and check. Now, the only thing I did not do is down here at the very end, I did not plug in, because some people were asking, the last one. Okay, if for some reason you skip one, and then what we're going to do is go to the stats page like before. We hit second stat, and we want two variable stats this time because we have two variables. We have an X and a Y. Okay, my data for X is in L1, and my other data is in L2, so I hit calc. What? Stat error? What does that mean? That means that somewhere in here you don't have the same number of numbers. You have to have the same amount of X's as you do Y's. And as I was telling you, I intentionally left one out. I left out 9 so that I could show you that. So now that I have the correct data set, and I don't have to put them in order from least to greatest, the calculator will handle all that for me. Second stat, 2 variable stats, L1, L2, and calc. Boom, there we go. So get a mean, you get all this other stuff, and we're looking and we're like, what's going on? There's the average for the Y's, which are your L2s, right? So the average test score is 24.9. The average number of books read is 10.4. Some other information. You don't need to know what most of this means. If you want to ask me, you can ask me. What I do care about is this. For whatever reason, when they do this for their best fit line, the formula becomes y equals ax plus b. Don't freak out. It's nothing crazy. A is just the term that they're using for m. So that's just your slope, right? That's the slope of the line of best fit that goes through this. So if you were to graph that line back on that graph page, scatter plot page I showed you, it would be the one that best goes through the center of that data, okay? Now, we're going to round. We're going to make our life simple here. I'm going to tell you that we're going to round to 1 decimal place. So that's what we're going to do. So 1.8x plus, and then my b value is your y-intercept, just like always. We're just going to go ahead and round that one to 6. So plus 6. All right. There we go. So what does that mean? That means, think about it, what we talked about in the last lesson. 6 would be, if you didn't read any books, you would expect your score to be about a 6 on the test. And then per book you read, it would go up 1.8 points on the test, right? So basically it's points per book. So about 2. You can get set to go up about 2 points per book you read, if you were to round that up. Now, those are important, and that helps us do our best fit line. And then we have this, our R value. R is 0.48. R only does one thing. It tells you the line, what kind of fit it is, right? So the closer this is to 1, the stronger the linear function would look. And we already knew by looking at the graph that it wasn't a very strong linear function. Those dots weren't really super close. However, it does seem to have some sort of positive correlation, okay? Now, that means that this one has a weak positive correlation. There is a little bit of a connection to the data, but not much, okay? Now, I'm going to stop the video here, but one thing I do want to say, and this is probably super important, when you do these calculations in the calculator, you will almost never get a correlation score of 0, right? Your R value will almost, no matter how scattered the data looks, your calculator is not going to tell you that it's exactly 0, okay? I'll try to make it where, it's not much more scattered than the one I just gave you here. But what I would like to say is this: if you get anything less than about 0.2 or negative 0.2, like if you're closer to 0 than either one of those 2 decimal points, you can pretty much say that there's no correlation. I've never seen a question where they gave you something less than a 0.2 and said, does this have a correlation or not? Pretty much it's always, if it's supposed to be weak, it's usually in the 0.5 or 0.6 range. And if it's strong, it's usually in the 0.8 or 0.9 range. Okay?